Hey everyone, this is lab number 10, observing chemical reactions. This is going to be a two-part lab, and in the first part, you need to watch the video that Scott made that's on our YouTube channel, and you need to observe chemical reactions. In part one, all the reactions we're looking at are going to be precipitation reactions. So remember what a precipitation reaction is we take two aqueous solutions containing ionic compounds, we mix them together, and we form a solid. We form an insoluble precipitate. So when you observe these chemical reactions, what is a precipitation reaction going to look like? Well, if you're forming a solid, the solution should get cloudy, it should get milky, you should have this precipitate, this solid form. So that's what you're really looking for in part one. Okay, so let's look at this table on page 92. Everyone sees this table on page 92. All right, the video follows this pretty well. And in the beginning, let's look at like the top part of, let's look at the top row of this table. So the reactions we're first going to look at in Scott's video, he's first going to take an aqueous solution of potassium iodide, and he's going to react it with all of the following solutions. So we'll be filling out this table kind of a column at a time. All right, so notice that we're not going to react potassium iodide with potassium iodide, right? So we can take this diagonal and we can get rid of it. We're not going to react each reactant with itself. Also, if we filled out this entire, man, I'm so bad at this. All right, if we filled out this entire table, we would be looking at every reaction twice. So that's why the second half of this table is X'd out, because we don't need to look at every reaction twice. Also, the diagonal is X'd out because we're not going to look at each reactant react with itself. All right, so that leaves us with needing to observe the following chemical reactions. So if we follow Scott's video, again, it will start with potassium iodide and react it with the following solutions. Then it'll move to copper 2 sulfate, react it with the following solutions, so on and so forth. So as you're watching the video, you need to be on this table recording if you see chemical reactions or not. If you see a chemical reaction, record your observations. It can be as simple as reaction or precipitate formed or bright yellow solid formed, something like that. If there is no reaction, if there is no precipitation reaction, just simply write no reaction or NR or leave it blank. I don't care. What you then need to do is for all of the reactions you see on a separate piece of paper, you need to write a balanced net ionic equation describing that precipitation reaction. Okay, we're going to make this straightforward because it's kind of hard to see all of the reactions in the video, but I would say you should at least see 10 reactions, maybe more, but at least 10 reactions. So what I want you to do for all of the reactions you observe, I want you to pick your favorite 10, the 10 you feel most confident about, the 10 you feel most sure about, and write net ionic equations for 10 of the reactions you see. You should at least see 10, so write 10 net ionic equations. If you see more than that, great. I only need net ionic equations for 10 of the reactions. Okay, so how do we do this? Well, let's just go really quickly and look at the video. So the first reaction is going to be potassium iodide reacting with a solution of copper 2 sulfate. And Scott will mention all of this in the audio in this video. Let's see. Okay, here we go. He mixes his first solution. Lovely. He mixes copper 2 sulfate to this. Eventually, oh, there we go. Bam. This is clearly a reaction, right? So we need to, in our table, in the appropriate place, that would be a reaction of potassium iodide with copper 2 sulfate. We need to record our observations. Maybe brown precipitate formed or something like that. We keep going through. The next reaction will be potassium iodide with sodium sulfite. Does it look like a precipitate is formed? Do we form a solid? No, doesn't look like any precipitate formed, right? So that would be no reaction. Okay, so you need to go through the table and you need to watch this video and you need to record your observations. What I want you to do on a separate piece of paper is write net ionic equations for 10 of these reactions. So let's say you should at least see 10 reactions. I want you to write net ionic equations for these. One example would be, how about this? Potassium iodide. We'll just stick with this first column of reactions. When it mixes with lead 2 nitrate, there is a clear yellow precipitate formed. Okay, how do we figure out what that precipitate is? How do we write a balanced net ionic equation for this? All right, well, we know that a soluble ionic compound completely breaks up into ions. So writing AQ next to an ionic compound is the same as writing it broken up into its ions. Soluble ionic compound, so that's the same as writing it as its broken up ions, which are lead 2 and nitrate, but we need to balance it, right, because we have 2 nitrates. Cool. What are the products going to be? So now we have all 4 of these ions floating around in the solution, and opposites attract, right? So our cations are going to combine with our anions, so positives combine with negatives, and vice versa. So what are the products going to be? Lead is going to combine with what? It's going to combine with the other anion, so I minus. Lead's a 2+, I is a -1. So what's the formula for lead 2 iodide? PbI2. What's the other compound? Potassium will combine with nitrate to make KNO3. Right, there are products. If we saw a reaction, one of these 2 must have been the precipitate. All right, we can use solubility rules to help us if we want, but we need to be able to determine what the solid is. And it turns out that the lead 2 iodide is the solid, is the precipitate, and potassium nitrate is soluble. Okay, we need to balance this reaction. How do we balance it? We got 2 nitrates. We need 2 nitrates over here. So how about a 2? 2 potassiums, 2 iodides. How about a 2? All right. This is a balanced molecular equation. That's great. But what I want is a balanced net ionic equation. So to get our net ionic equation, we need to understand what can be broken up into ions. We cannot break the solid up into ions because it stays as a solid. It is insoluble. Our other product is soluble, so it breaks up into ions. Then we simply see what changes and what stays the same. Okay, I'll assume you're all learning about this in lecture, so we'll move kind of quickly. Notice that, oh, I didn't balance it. Shit, sorry. Notice that potassium doesn't change. It's just K+ swimming around in the beginning, K+ swimming around at the end. So K+ is a spectator ion, doesn't do anything. Iodide, sorry, that changes. What's our other spectator ion? The other spectator ion is nitrate. NO3 in the beginning, NO3 at the end. it doesn't do anything, right? The only things that change, in this case, lead 2 combines with I minus to form our solid precipitate. So when we cancel spectator ions, we are left with our net ionic equation. So the net ionic equation is simply lead 2 combines with 2I minus to form, erase all this, to form our precipitate lead 2 iodide. So notice for precipitation reactions, the net ionic equation is simply going to be the precipitate we form and the ions that formed it. Everything else will be a spectator ion. So for 10 reactions for part 1, I want you to write balanced net ionic equations. This is a balanced net ionic equation. Great, so now you only have to do 9 more. All right. I hope that makes sense. What if you see no reaction? For example, Ki plus sodium sulfate. I'm sorry, sodium sulfite. We saw no reaction. So do we write a balanced net ionic equation for this? No, there is no reaction, right? No reaction. So only write balanced net ionic equations for reactions that you observe. Okay. Part 2 of this lab, again, you are simply observing chemical reactions and writing balanced net ionic equations. For part 2, we're going to look at some oxidation reduction reactions. And we're going to look at some acid-base reactions. Okay, so observe chemical reactions on the video for part 2. You should observe, let me just make sure real quick. Sweet, so we're looking at a couple redox reactions, sodium and calcium and water. We're looking at a couple acid-base reactions. And for these 4 reactions for part 2, let's see if you can see this. There's your first 3. You need to write a balanced net ionic equation for these 3 reactions. And then I think there's a 4th on the next page. Yes. Okay, there's the 4th. All right, so for part 2, you should be making observations for all 4 of these reactions and writing net ionic equations. I would suggest for part 2, these reactions aren't necessarily intuitive. Like I wouldn't expect you to know perhaps what the products are just by looking at the reactants. I would suggest looking up the reactions for part 2. Like you can look in your book or Google search, sodium reacts with water, to figure out balanced net ionic equations. All right. I'll talk to you soon.